Burning current time in the flesh. Here comes the algebra. Shut up, Mitchell. Sorry, Matthew.
All right, and it's burning current
All
time.
right, what's up, everyone? Just wanted to throw together a quick scatterplot example problem here to show you and post on Google Classroom in case you're getting stuck working on homework or maybe even studying for the upcoming test. Like I said, scatterplots is definitely one of our big chapter 1 concepts, and there's a few different, examples we could do, but I put one together here where you see a graph on the left and a table on the right. All right, so this graph is looking for a relationship between the number of late arrivals and someone's grade in terms of percentage, right? Is there a relationship or an effect on how many times someone is late to class on their grade? All right. So when you get these problems on a homework or on a test and you do them, right, you're going to be asked, given this table, to plot these points, right? Every point along this graph, or along this table, needs to be plotted on your graph. All right. And I've already done that here. Okay. So first let's talk, right? We got number of late arrivals, which is our X value. So you see it labeled down here along the X axis. And then you've got grade percentage, right? Labeled up here along our Y axis. Every good graph or scatter plot has labels. Okay. So again, quick review on independent and dependent variables. Number of late arrivals is not dependent on what someone's grade is, right? So we would call this our independent variable. Always goes on the x-axis. On the flip side, someone's grade could depend on how many times they are late to class. So their number of late arrivals. So grade is our dependent variable. Grade could be dependent on how many times you are late. So that's why it's on the y-axis. All right. So for example, right, when you do this on your own and you have to plot the points, quick review here. So if I had 12 and 65, 12 late arrivals for X, I would come down here, right? I'm labeled every 2, but every 2 blocks is actually 1, right? Every 1 block would be a half. So pay attention to the scale. So I would go over 12, which is right here, and then up 65. And it would be right there. Because on the y-axis, I plot that point. And you would do that for all the points you get in a table. All right? So going up on the y-axis, just checking out the scale real quick, it's labeled every 20, right? Which means every 1 block. So we got 0, this would be 5, 10, 15, 20. So make sure you're paying attention to scale, all right? And looking at what they give you in terms of what's numbered, and then determine what it's actually going by when you plot, all right? So don't make a silly mistake there, all right? So we've got all these points plotted, right? These are actual data points that you see from our table now on our graph, all right? Your next job is going to be, okay, I need to draw a line of best fit, which is also known as a prediction line, through the middle of these data points. All right, through the middle of these data points. And you can see, right, remember, a scatter plot means the data points do not fall in a perfect line, right? There is no line I can draw that is going to go through every single one of these points, all right? A straight line, that is, right? So again, right, we talked about positive versus negative. When our plotted points, when our data points are kind of working their way downhill from left to right, this is a negative relationship, right? If the points were working their way uphill, right, we would say it's positive. But we're looking at a negative relationship here, okay? So what you're going to do, right, and everyone's line is going to be different, is you're kind of going to draw your own line of best fit. And I'm going to do one right here. And I'm going to try to go through the middle of these data points. And remember that a good line of best fit has about as many dots that are above the line as there are below. So I wouldn't want to do this, right, where all the points are pretty much above. I wouldn't want to do this where most of the points are below. I kind of want to go through the middle, something like this, right? Is it perfect? No, right? Could I do better? Probably, but it goes through the middle, right? It's a decent line of best fit. It could work. Okay, I got 1, 2, 3, 4, 5 points above, a couple that the line went through, and I got 1, 2, 3, 4, 5, 6, 7 below. So I could have done maybe a little bit better, but it's actually pretty good. All right, so that's a good line of best fit. It goes through my data, and you see it going downhill. All right, what that tells me is as number of late arrivals increases, right, as number of late arrivals increases, typically that means that students' grades decrease, right? It's an inverse relationship. As our as our X values increase, the Y values decrease. In this case, late arrivals increases, grades decrease. That makes sense. All right. The last thing I want you to be able to know, okay, is if I asked you to predict, right, using this line to predict. So if I ask you the question, right, predict the grade using this line of best fit you've drawn, and everyone's would be a little bit different, but using the one I've drawn here. If I said, okay, for someone who's missed 16 classes or they've been late 16 times, what would you predict their grade to be, right? So if they've been late 16 times, to predict their grade, I would say, okay, they've been late 16 times, so I need to come down here on the x-axis where the late arrivals are at. 16's right here. Now I need to go up to where my line of best fit is. Oh, there it is, right? Right about here, okay? So now, right, if this is for 16 late arrivals, I got to come over to the y-axis and see where that number's at. So I would say, okay, someone who misses class 16 times, or they're late 16 times, they would get about 45%, right? I would predict that they would score about 45% in the class, maybe 46. Remember, right, there's going to be a range of right answers. You don't have to be exact. You just have to be close, right? You can't give me something like 90% or 10%. You have to be close. So according to my line, right, again, I came over to 16, and then I went up to where my line's at that point, at x equals 16, and then went over to the y-axis, and this is about 45%, maybe 46. You maybe say a little bit higher because the line's slightly higher, right? Again, remember, right, the y-axis is scaled by 5. So if this is 40, this is 45, this would be 50. So I'm at about 45, 46% would be my predicted grade, right? And you could do that for any value. Last thing, really quick, right? I can go the opposite way, right? What if I said, what would you, if I said someone who has a 60% in the class, right? Their grade is a 60%. What would you predict to be their number of late arrivals according to our scatter plot and our line of best fit? So this time, right, if they give you the grade, go up on the y-axis where they're talking about grade. Well, 60%'s right here. And again, go over to where it meets your line. That would be right here. Now I've got to come down down to the x-axis where it's talking about number of late arrivals, and you kind of got to take your time. And that would be right here, right? I would say, okay, someone with a 60% in class, I would predict would have missed about 11 classes, or they've been late 11 times, right? Their number of late arrivals would be 11, right? Because at 11 late arrivals, boom, it's at 60%. So that is how you use the line to predict, okay? And finally, one really last quick note on scatter plots, right? If I'm talking about the correlation of this, right, my points aren't super, super close, right? So I wouldn't really say this is like a very strong relationship or correlation, but they're not super far off either. So I wouldn't call it weak. I would say it's like medium strength correlation, right? It's negative, all right? And the points are fairly close. So I'd say it's about a medium strength in terms of correlation. All right, so that is it on scatter plots.